vibes, kicking a map, whoa. Microphone phenotype, opening third eye, seeing through the overground. I'm about to hit you with a scream from the underground. Whole city's covered with a cyber flavor, G's in your area. But now with the top best, impossible, see invisible. Row, row, fight the power. Touch the untouchable, break the unbreakable. Row, row, fight the power. What you gonna do is what you wanna do. Just break the rule, then you see the truth. This is the king of the cheap. Cool, baby. Row, row, fight the power. Impossible, see invisible. Row, row, fight the power. Touch the untouchable, break the unbreakable. Row, row, fight the power. What you gonna do is what you wanna do. Just break the rule, then you see the power. This is the king of the cheap. Cool, baby. Row, row, fight the power. Impossible, see invisible. Row, row, fight the power. Touch the untouchable, break the unbreakable. Row, row, fight the power. What you gonna do is what you wanna do. Just break the rule, you fight the power. This is the king of the cheap. Cool, baby. Row, row, fight the power. Row, row, fight the power.
Okay, yeah, we were on multiplying. So, last we left off, we got to multiplying, more math, my favorite, absolute favorite. And, whoops, my phone was loud. Sorry about the just absolute lack of, just like, going live. My job's been kind of physically demanding, but it's no big deal. I love it. It's a great job, actually. But, sometimes your job demands a bit more of you than it normally does. And gotta recuperate. I've also been kind of obsessed with Voices of the Void as of late. So, you know, there's that. But I'm back. I'm gonna be streaming probably 2 or 3 hours like I normally would. But how far into this are we? Yeah, we were past the halfway point. I remember that. Now, okay. To work. Our robot's health is always between 0 and 100, but as our robot fights, he wants to increase its strength and toughness. When a character levels up, it might deal more damage to enemies, gain new abilities, or in our case, gain more health. We define a level variable. Track a robot, starts at the level. When defeat enough enemies, you call a level up function to increment the robot's level. Okay. As we briefly saw in the last lesson, a robot could have a range of variables that would increase levels. Okay. Now we're starting to get into some shit that I recognize. In this level, we just focus on increasing the robot's max health. The variable max health is the maximum amount of robot's health can be changed. Any function uses this variable. Heal amount plus amount. If health is greater than max health, health equals max health. Okay, yeah, that's easy stuff. Whoa, what is up with my camera? Also, I am a little... the hell? Great, now I gotta wait for this. Oh, I'm looking at the... Okay. Yeah, that seems about what I want. Yeah. Listen, I'm not a professional at this, so... Okay. We could add 5 to max health every time the level is up. Level up equals level plus 1 max. Okay. That was my phone. I should probably put that on vibrate. At least for now. Where is the vibrate function on my phone? My phone! Alright, cool. This would increase the max health the same amount every time. If we graph max health, it will look something like this. A linear increase, yeah, sure. In case we want our feeling to be more and more power as robot levels up, we want to graph like this. Sure. This is our growth exponential. With each level, more max health is added than the previous level up. To get exponential growth, we are multiplying max health by an amount greater than 1 each time the robot levels up. To multiply, we use... Yeah, that makes sense. What is the value of damage? This is the level. That's the power. Function. Damage equals power times level. So 5 times 3 is... 5, 10, 15. Oh my god, I can't believe I had to do that. I'm not good at math! Okay, what is the value of the damage now? Okay. So 15, but damage... Okay, so it does the 15, and then it multiplies that by 2, which would be 30. Yeah, okay. A level robot exponential growth. I guess that would double the damage every time, yeah. I think? I don't know. I'm not even going to get into that. Level robot exponential growth. In practices, you increase the robot's health and add a special ability to our robots to make extra tough at high levels. Alright, let's rock. Alright, let's make the robot stronger when he levels up. Add the level up function, right? So it does the following. Increase level by 1 10%. Not 10%. Increases level by 1. Level 1. So what is that? Level equals, or wouldn't it be plus equals 1 and then increase max health by 10%. Well, not just be, well, 10% of 100 would be 1, right? So, or will be 10. So max underscore health plus equals 10? Multiplication. So then that would be times equal. Yeah, because we're talking about multiplication. I thought it would kind of build up to that. So wouldn't that be 0.1? I don't get it. Okay. Multiplication is not the correct value. The health just made it to 1. Again, math is not my strong suit here. So, can I just put 10% then? That's fucking stupid. Okay, let me go back. So I was right. My gut reaction was right. I just needed to add the 0.1. I'm stupid. Okay. So increase level. Yeah, that's an L. Level plus equals 1, and then max health plus times equals 1.1. How is that 10%? Because like, because if 1 is your 100, like if for example, if 1 is 100, 1 is 100% of 1. So 10% of 1 would be 0.1, right? It wouldn't be 1.1 because 1 is 100% of 1. So 1.1 would just be 10%, unless you're saying that the 1 has to be accounted for, because if you multiplied it by 1, yeah, because multiplying by a decimal actually divides it, because math is weird. So you have to take into account that it's already 100%, which would be 1, and then you add 10% to that, which would be 0.1. Sure? All right, I guess. Listen, math is not my strong suit. So I would get a calculator or something with that. When our robot's level is 3 or more, we want it to take a lot less damage. Add take damage functions so the following happens. If the robot's level is greater than 2, reduce damage by 50%. So would that be 1.5? I'll try that. I will certainly try that. Take damage, health minus amount. If robot's level is less than 0 than 0. Okay, I don't need that. That needs to stay. If level is greater than 2, reduce damage taken by. So then amount, right? Is times equal 1.5. Oh yeah, you need the syntax for this one is a little weird. Damage value is taken correct. Do not take half damage despite being level 3. Okay, so that time it's 0.5. But then it didn't even work. Does it need to have the 0? No. Did you multiply the amount by 0.5 to reduce it? I did. Does it have to be? Well, yeah, it probably has to be above it then. If level is greater than 2, amount times equals 0.5. What? $0.5? No, it's 5.2. Yeah. That should be it. It's the exact same thing. Oh, indented block. Unexpected indentation. Reset. Okay. Level is greater than 2. Oh, this needs an indentation. Yeah, again, the syntax is definitely weird. Amount. Do I... Oh, you know what? Amount is times equals 0.5. Health minus equals amount. And then we do this. That should work. Or not. It appears to be taking 0 damage when the level is less than 3. Did you subtract the amount of health when the level is less than 3? Huh? The character appears to be taking 0 damage when... But it's not. It was at... So it just... No! Because its health starts at 100. Okay, let's try this then. We're going to brute force it then. Reduced damage. Unexpected assign. There's something that is syntactically invalid. You're missing something to complete the line on previous. That doesn't make any sense. Yeah, that don't make sense. Okay, so I guess you can't do that. Is greater than 2. Amount is times equal 0.5. Did I not do that last time? Am I losing my mind? Like, did I not try that? Okay, whatever, man. Whatever. Suppose we want to increase the size of the robot when it levels up. As you may recall, we do this by the following code. Plus equals 0.2. Would that be a doubling? Or just adding adding 20% to its scale? See what I'm saying? Like, what? As we talked, the variable has 2 variables because for 2-dimensional vectors. This is because scale is a vector 2, which stands for 2-dimensional vector. What are vectors? A vector in physics is the quantity of magnitude. Vector! Quantity in magnitude. Force applied to an object. Vector 2. Unlike plane numbers, they store 2-dimensional numbers. One for x, one for y coordinate. There's a vector. So far, you've come across 2 variables in the course, which are vectors. What are they? Position and speed? There's position and scale. Yeah. Look at that little boy go. Characters' movement, speed, and direction. Calculate the distance to a target and move with little code. Take this turtle AI below. You've probably seen games where enemies move like this. This is done just 7 lines of pure vector calculation code. The code is a bit too difficult for now, so we'll spare you the details, but this turtle is a glimpse into what 2D vectors can do for your game. We'll scale a robot again, this time adding directly a vector 2 to the following code. I wonder how big this boy can get. Look at that. Look at how big that boy is. Notice how the parentheses are 2 arguments, just like other function calls. Constructs a new vector within its X to set. Respectively, we can add subtract vectors. If you want a robot, new relative to position. Okay, yeah, no, that makes sense. How would you move the robot 50 pixels to the left? To the left. No, this one. Ha ha! We got it, we got it, we got it. Okay. Add a line of code to the level up function to increase the scale of the robot by this every time it levels up. Much like the other times. Man, holy crap. Much like the other times, it kind of... isn't declared as a current class. Maybe it has to be capitalized. Yeah, okay, so it's its own thing. It has to be capitalized. That kind of makes sense, really. Robot's level has increased a lot, so it has... Oh, Jesus. Let's fix it by resetting the scale and position values. Create a function named reset robot. Robot. Oh, cool. That sets the scale. Yeah. I'm silly. Must think about robots. Oh my god. Resets scale plus equals vector 0, and then position plus equals vector 2. Nope. Yeah, moves it. Whoops. That's not what I meant to do. X and Y variables are what needs to be 1 point. So just 1 and 1. No, position needs to be 0. I read that wrong. So not only am I bad at math, I'm just kind of straight up illiterate. Although my first gut instinct was that, but I thought there was going to be some kind of... What? Is it declared in the current scope? What? Oh, that's because I just totally missed an I. I like how I can't see them, but... Wait, what? It didn't even work. It isn't reset using directly or via... Is it not? But then it goes through... Oh, I didn't see that. Use vector 2 to reset robot. Huh? I don't understand. I don't need to plus equal it. Even though that would work, because it technically works. I would love to be able to click anywhere else. This really struggles with that. I hope that's not something that happens in the actual Godot program. That worked, even though it doesn't look any... Whoops. Well... sure. I mean, it worked. Func... Ro... What I keep thinking of, like... I don't know, a weird way that you could say a robot. Keep putting robot. Coolio. Alright. Cool. Introduction while loops. You've seen that functions can reuse code. You'll learn that about loops. Our robot can move to neighboring cells. Change vector to enable main cell. Cell! Neighboring cells by changing vector variable named cell. It represents current cell robot as N. We increase cell X. Cell X! The robot moves to the right. Okay, went all to the right. Note that we delay the robot's movement in the app to help you visualize how it moves. The following code would move robot instantly. Okay, yeah, because it's called twice. Yeah, okay. We can move diagonally by adding vector. Because then... What? Yeah, no, because... Yeah, the positioning, because it goes down. Yeah. The above code works for a predefined board with a size of vector 3x3, but move to end function wouldn't work if the size of the board was different. The robot would either stop before the end or go too far. To have a general solution for board sizes, we could repeat the board's movement until it gets to the end. For code repeat, we use loops. While. You can use while loop. Here's how you use while. Number is equal to 0. While number is less than 4, print the number, and then add the number, add 1. Yeah, that makes sense. Step, run, variable is 0. Yeah, see? But honestly, if you wanted to get it to 4, you would want to print it so that way you know it gets to 4. But, whatever. Let's apply the move to end function. This time we compare the move to end. Note that the robot's position is 0 until it's less than the board's width. Or x by cells with coordinates from going to 0 to 2 from both x. Okay. While cell x is less than the board size X, which I can't seem to change. Yeah, let's make it big so I can see it. Less than the board size X, so whatever this is, so 9. Cell, you move over Oh, well, this is how wide the width. So the width of it is 9 minus 1. I guess that's because it's already in 1. Then you add 1. Oh, minus 1. Yeah, because you're already in 1. So, yeah. Indexing. Yeah. While the loop can cause issues, well, loop can run indefinitely in that case. Well, application will freeze. Take a look at this code. What would happen if you tried to run the code above? Well, yeah, you just told me the solution to that, but why? While number is less than... Oh, yeah, because there's nothing to add to the number. There's nothing to stop to reach it to this number, so it would just draw squares. Yeah, we don't increment the number. Yep, see? Told you I knew what I was talking about. I have some idea of what's going on. At first, you will not need while loops often. Even code we show has more efficient alternatives. Safer kind of loop for loops, which we'll look into the next lesson. While loops, blah, blah, blah. Reading and processing a file. Yeah. Okay. Actually, so that... Man, holy crap. Oh. Ew. Let's get it done. Okay, complete the move to the function so the robot moves to the bottom of the board, which would be Y. The board size is determined by vector 2. Variable named board size. Okay. All right, yeah. So the board size is determined by vector 2. The robot cell. Starting cell is that. It's XY, so XY. Y is 0. 1, 0, 1, 2. Yeah, because indexing. Make sure while you use while loop, the function for any board size. I can literally just write that down because that's exactly the same. Where is it? And then I had a pen somewhere. Booyah, I got a pen, boys. You know, I actually used this notebook while I was in school. Yeah, personal communications class. Whoops, I just hit a button. Hopefully that didn't do anything. It's nice to know I still doodle from time to time. I'd love to actually, like, draw and stuff, but I don't know. I don't need a blank piece of paper for this. I just need to, like, scribble it down somewhere. What am I doing? I'm just, like, compulsively looking for an empty paper like a moron. I need to change my desk back today, actually, too. I think I'll do that. Make sure it stays clean. Okay, so func move to end while cell Y for our instance is less than the board underscore size at point Y minus 1. Then you're going to have the right syntax. Cell Y plus equals 1. So we got the backbone of this ship. Func move to the bottom while cell Y is less than board size point y minus -1 cell point y plus equals 1. Whoop, that's not a thing. Run it, man. What? You will error something that is syntactically invalid. Huh? I guarantee it's because I can't spell. Yep, it's exactly that. Because I'm the most... Huh? Wait, maybe it's not. Oh my god. Oh, it... What did I do wrong? Oh, indentation. It's so weird with that. Oh, I'm already... Yeah, what? I couldn't spell. It's my spelling, 100%. That's what I put on my paper, so I just... Maybe it's the font just messing with my brain or something. I don't know. Board size point y minus 1. Oh, wait. Before I forget that. Cell point y is plus equals 1. Let me guess. Indent. I promise I'm not that stupid. I promise, guys. I promise. For loops. In the last session, we looked while loops are useful. You don't know how many times. If we don't know, but while loops can result in infinite loops if we're not careful. For example, a loop will never end because we never increment the number. Say if you use your kind for loop while we look at this section. Unlike while loops, for loops don't run forever, so you're much less likely to get an infinite bug. We recommend using for loops instead of while loops because of this. In this example, I changed code for loop, and the loop will begin to change the cell 3 times. All right, for numbers in range of 3, I guess, cell plus equals vector down and right 1. Let's explain what's going on here. The Godot range. Calling range n creates a list of numbers from 0 to n minus 1. Because, yeah, indexing, so it has to subtract 1. So calling a range of 3 outputs the list of numbers 0, 1, 2, and a range of 5. Oh, it includes the index 0. Yeah, okay. Oh, range is in between. Yeah, in range of 1. Of, like, between the numbers between 0 and 3? Why? Has a helper function range. Call range n creates a list of numbers from 0 to whatever minus 1. Why? So because it indexes, because the 0 is there, right? But then it subtracts 1, so the number in range of 3, so it's every number before that number. Sure, I don't know why I would ever need that, but we'll submit that. Okay, in a for loop, computer takes each value inside a list and stores it in a temporary variable, executes the code on top of it. Step, run. For every range Print the number. Yeah, I don't know why I would do it. So really, you would want to do in range plus 1. For number, then print number, then you would just do number plus 1 to get it. Again, I don't know why, because like to me that's weird. If I wanted it to count to 3, why would I do the in range then? I would do in range of 4 to like compensate for that. But then again, I most likely wouldn't want 0 in there. If number is less than 1, then don't print the number, I guess. I mean, to me, that's just weird on how you would do that. I'm sure there's other ways to skin that particular cat. I don't know why I'm hyper-fixating on that. But, yeah, just like, I don't know. That's just weird to me. In above example, 0 sets the number in an item in for loop. When arrays, this is starting to sound familiar more thoroughly in the next section, but number is just a temporary value. The loop takes care of changing the value, also named variable. The code's behaviors. So step, run for element. Ooh, see, they should have been doing that. Element is 0. Print the number. Print the number. That's a brute force way to do that. Yeah. That's a brute force way to do that. And that would increment through all those numbers, which... Whew, okay, in both examples, set temporary values, which creates a number in the first element in a second. As Godot moves through the loop, it assigns each value of the array to that value, to that variable. First, it sets the variable to 0, then 1, then finally then to 2. We can break down the instructions as it runs it. You see how the loop shortcuts the code to otherwise get very, very long. Or very long. Why did I put the extra very there? Well, I'll be right back. I gotta do something. So, what was that again? Oh, Cult B? Yeah, let's go with that. Tell me if this works. Okay, we're back. We're back. I'm gonna have to probably mop that up again later. All right, okay. We're all hooked up. We're all ready. We're all set. Let's go. I got my new drink. I'm not going to spill it this time. Okay. We were reading this in examples. Number in the first example as Godot through. We can break down instruction, see how this loops. Okay. You're going to run it. The array. That's the element. Element is equal to the array. Huh, yeah. Yeah, okay. We can put whatever code we like in the loop's code block, including function calls. This. So, if we use a for loop for numbers in range of board size -1. This is like taking my coding classes all over again. I'm going to write this down. For number in range. Well, I guess in this particular instance, this is the one time where in range would be the number -1. I feel like that would kind of be redundant, though, because you have board size x -1. But that's to compensate for the fact that the robot's already taking up a space. So, sure. Cool. All right. I wrote that stuff down. Let's get into it. Okay. Yeah, see, I'm glad I wrote that. Move to the bottom. For number in range. See, I'm glad I wrote that down. Board underscore size y -1. It'd help if I actually spelled stuff correctly and not fat fingered all the time. So, what is wrong with me? I think it's because my desk is like cluttered right now. So here's what we're gonna do. Oh, good lord. Okay. Run it, man. Run it, man. Oh. Yeah, baby. I'm not stupid. Use a for loop to remove the duplicate in the run function. Then this practice we revisit the turtle drawing rectangles. Our knowledge of for loops, we can condense this. Okay. So he'll jump, draw a rectangle. All right, let's write it down here. Three squares. Do I need to define the number? Well, we're going to find out. I think I do, but I would love to be able to click wherever I need to when I need to. Yeah, baby! So I don't need to define it. I guess because number kind of gets defined later as it runs it. Awesome. Dude, I'm kicking ass at this. Got my programmer pants on. Pants. Oh, man. Range is a function we saw in previous outposts. Yeah, we know that. List of arrays values otherwise has precise name and code. We call it an array. Numbers or otherwise has precise name and code. We call it array. Calling the range function processes an array of numbers. We could directly use that array for a loop. Yeah. Yeah. Okay. As you can see, the code still works the same. Notice how when we create a for loop, if we unwrap for loop above, we'd get the following code exact. Yeah. This syntax of arrays and good. Whoops. Yeah, because it's in the brackets. Cool. So array just isn't defined by the brackets. Yeah, okay. When we start opening square bracket, then you write a comma separated values. You see closing square bracket. Here are a couple of valid arrays. Notice you can mix values. Yeah. Because arrays themselves are a value type, just like numbers or vector 2, we can assign arrays to variables and reassess them later. That'll come in handy in the next lesson. Vectors and numbers. Okay. But first we need to see when you'd use an array. The computer programming will use arrays all the time, precisely when you list of things, players, parties in an RPG, the items in the mirror's inventory, blah, blah, objects in the game world. All those and many more rely on arrays. In games, you need allies or monsters to find their way to the target. Whenever it's a player or some point of interest to achieve the pathfinding algorithms, so that all the algorithms pass between 2 points is allowed a traverse the game. Many of those algorithms use arrays of vector coordinates to repeat the path. Take this turtle pet. It wants to follow the robot, but there are rocks in the way. How can we tell it to walk to reach the robot? Okay, yeah, that's literally telling it where to go. Each value in the array represents a cell turtle needs to walk through. Together, all the values array represent that. Okay, cool. Yeah, no, that makes sense. It wants to meet the robot but cannot find it. Turtle path array with value. Holy crap, man. What the hell? Okay, so then this is a series of it. Path to robot. I feel it's got to be a cleaner way to do that as well, but you know, we're getting there. We're getting there. Victor. Victor. I'm probably going to end up doing that every single time. Quickly. Dude, this is still somewhat brute forcing that. Just a fancier brute force. Oh, we'll see. Look. Company. Sector. Well, that's some kids outside riding their little motorbikes. They say kids don't go outside anymore. It's a damn lie, and I'm happy about it. Just kind of minorly inconvenient, but I don't even know if you heard that. Alright. Oh, wait, no, I know. Alright, yeah, we're good, we're good. Alright. Oh, okay, I have to put in the last one. Yes, eat the robot! Now we run it. Excellent. Select units. Alright, this ought to be... In this tactical game, the player and computer can select multiple units at once. You need to call the select units function and pass it in an array of vector coordinates, which units to select. Each vector 2 array represents a cell with a unit. Array. And pass it an array of the coordinates in which where they stand. Each, represents where they're standing. You can pass array function calls as arguments. As an array is a value type the computer recognizes, you can pass the whole array in a single function argument. Select all the units on the board by passing the correct array. Only units are selected. So... select your units. Select the units at vector. At that unit, then select act. This location. So that'd be 5-1. And then don't forget Buddy Boy over on be 4-2. 4-2. No, 4-2. Yes! Looping over arrays. If you show me this in range strat, again, to tell me what array. Yeah, I get ya. For each inside the array. For each element inside the array, for loops extracted stores in the temporary variable named number, which changes on each iteration. Yeah. Making sure in previous lesson, walk path. And for a loop that makes the turtle walk along the path. The loop works for like this, the coordinates in the array, turtle, move path. For cell in path, move turtle. For each coordinate in the array, select units. If we check there's a unit. So select units, selected units. For each function, select units, cells. For cell in cells, if cell in units, select units, append, update. What? The code above. In condition, in keyword allows you to check that value exists in array. The array append function appends a new value at the end of each array. Notice uses period is selected after the selected unit variable to call append function. Yeah, because append just changes it, yeah. It's because the function only exists on arrays. When function exists only a specific value type, you write a dot after the value to call the function. Wait, so notice the append after the selected units variable to call append function. It's because this function exists only on arrays. When the function exists only a value type. Okay. Those, yeah, okay. The beauty of the loops is they work regardless of the size of your arrays. The code just works whether you have 1 or 10,000 and select all accomplished. Robot path, run. AI path founding remove. It's just a robot. Right, your task is to use a for loop. Well, let me go back because it's here. I'll give it that. I'll give this learning thing that they basically kind of give you the answers, but that could backfire in a different way. Because then you're just like, oh well. Move underscore to cell. All right, I just got one second, guys. I'm just gonna list them. Right, I think that's it. Yeah, that's it. One sec. Okay, sorry about that. Okay, so I wrote down the thing. Let's go to the lesson. So I'll probably just do it like this. Okay, hold on. AI path to the right edge. Your task is for loop to make the robot move. To move the robot, call its to move function like so. Robot to move. To move function only exists on the robot, which is why you need to access this way. Oh, I wrote down the wrong thing. But oh no, wait, no, I didn't. No, I didn't. So let's see how this turns out. Oh, wait. Huh? Path isn't declared in the current scope. That's because it's not. Cool. Okay, we want to draw many rectangles, something surprisingly common in games. However, writing this code by hand can get tedious. Instead, you could store the size of your shapes in arrays and use the loop to draw them all in batches. That's what you do in this practice. For loop to draw every rectangle. Rectangle. Draw rectangle function. So cell and path. So there's no append here, so. I have to do that again. Ooh, excuse me. Holy crap, man. Oh. I'm just prone to fat fingering stuff, I guess. So for Okay, focus out. For I guess then. Rectangles shouldn't overlap. Sorry, y'all. Okay, I want to draw many rectangles. How this is going to do for loop to draw every rectangle in rectangle sizes. So cell in path. So it would be for rec. It just would be rectangle. Rectangle in rectangle sizes. Draw rectangle goal. Jump rectangle draw rec. You know, if I could actually. Isn't declared in the current scope. Let's just look. That's the sizes. For size, why is this size? Why is this size? I guess that's just the temporary name for it. So I guess that could technically work. Let's just not change that and see how that works. I would love to be able to click wherever I need to. Draw rectangle sizes. What would be X then? Well, this has to be because this is size. But what is size for each? This is the size, right? Rectangle sizes. So that's the size of the rectangle. X. Okay, so it stores the two variables. So size X would be this, size Y would be this. But then where is this coming from? You know what I'm saying? Like, where is this size X coming from? and then this is 0. So it's just jumping these? I kind of don't really get how that's working. What if I do just like 100 0, right? Why is that not defined? Draw. The argument. Yeah, but where? Okay, but I know this is size X, right? Oh, they're all connected. So it jumps that distance to be on that line. My handing is tedious. Rectangles shouldn't overlap or cross each other. To avoid that, we're going to say the size is the vector. You'll need to access X and Y subcomponents to draw the rectangles. That's this. In the loop, you first need to call the draw rectangle, then jump. Otherwise, let's to overlap. Okay, that makes sense. That explains that. The arguments are willing to call jump just to be large enough. Just to be large enough to space out the rectangles. For example, jump 300. Huh. Yeah, I kind of get that. So, yeah, that makes a bit more sense now. Sure. Yeah. Alright, strings is how you, like, name stuff, I think, if I'm remembering correctly. Throughout this course, we're storing numbers and variables, but what if we wanted to store a player's name? Where strings help us, strings are independent game explanations, strings are variables, string. For example, right? Under the hood, for characters in each string. Yeah. Perform combo for each item play animation. Yeah, okay. What time is it, yo? Think we'll at least look at the next one because this one was obviously pretty short. Currently, your robot has a number stored in the robot variable. Change the robot's name variable so that it's a string instead of you can give the name you'd like. Robot name is. Okay, cool. Cool. Yeah. In this practice, we'll chain together animations using the string array. Jab makes jab, uppercut. Populate array with. In this practice, we'll chain together animations using an array of strings. You might find such combinations in fighting games. So first of all, jab, jab, uppercut. Populate the combo array with animation name strings for each and make sure to use each. Okay. Play animation function for each animation. Use a for loop and play for each animation in combo play animation. Oh. Too few arguments for what the fuck am I looking at? Ah! Isn't declared in current scope? Oh, well, animation. I did. Is it correct? Did you use the right actions in the right order? 2 jabs followed by 1 uppercut. Why? That's almost 1 for 1. Is it really a naming thing? Because if it is, that's kind of stupid to not tell me that. Oh, well, you have to be kind of precise with your names. No, it isn't a naming thing. So I'm going back to how I was doing it. That should work. Like that's 1-to-1. Oh. Functions that return a value. Cool. Imagine you're in game player's health as a percentage of the decimal. If you don't want to show the decimal part, notice how we assign the results of functions called because the round function. If you need to return a value, cooler example, lerp. The lerp function is short linear interpolate, bends between two values. It takes three arguments, a start value, an end value, and blend the amounts between 0 and 1. That controls the blend. A value of 0 gives you the start value, the end value, and 1 gives you halfway between. In games, lerpers used to make things move smoothly towards a target. Encode lerp function across multiple lines. Readability works. Okay, so process delta. Position equals lerp. Position, get local mouse position, and then delta. Delta is over time, yeah. Most robust, smooth movement. You can make your function return values. Not the most robust approach to smooth movement as you'll learn in the future, but it's helpful. You can make your functions return values. To make a function return a value, you use the return keyword. In previous lessons, we had characters walk on grids. For those practices, you were working in cell coordinates. But cell coordinates are not the same as positions on screen. Cell coordinates like vector 2, but not where it is in pixels. To draw something on screen, we need pixels positions. Function to convert all cell coordinates to pixels positions. Hover over the cells to below. Okay. To convert all cell coordinates to pixel positions, we must look at these sides. For example, it's these cells 120 pixels wide. Then this gives us the top left corner of each cell. Things on grids and games. The function below does the calculations and returns the results so we can store it in the variable and use it the right way. Convert world to coordinates. Cell equals times cell size. What? For example, each cell is damn it. Use interactive grid. If each cell is 120 by 120 and is a pixel position. Alright. This gives us top left corner. Convert to world coordinates cell. Return cell times. What happened? Okay, that was weird. I don't know why that happened. I think I might have bumped the cord or something. Though we write coordinates, the value goes left to right. In the album, we call a function to store return value in the variable. Huh. See results. Cell size equals 120 by 120. Run world position, convert world to coordinates. Vector 1 to 1. World position. What? Some functions return values. Okay, this is starting to get kind of heavy. And I think I could probably do it, though. Mission panels and coordinates. Okay. Complete this function converts all cell coordinates to pixel position on the screen. I know this one. Let's try this. Cell times cell size. Is equal to cell times cell size. Oh, I gotta return it. Return cell times cell size. I still don't get what this is for. Okay, now is a solid place to stop. I went for a little while, actually. I think 2.5 hours this time. Either way, though, I kind of get the hang of it. I'm getting my programming pants on. We've got to be close, actually, to the end, if I'm recalling correctly. Yeah. Honestly, we'll probably be able to finish this out either next stream or stream after that. But, yeah, thank you so much for stopping by. I got to start uploading these VODs to the other channel, so that way you can go back and see them. The lives are going to be in the videos, I think, if you look up at the channel, but I got to start moving them over there, because then I'll probably do announcements and such over there. But I'll work on that. Probably I'll do that tomorrow, to be perfectly honest, because they don't take too long to download, but, you know, got to edit them, put even the most basic of thumbnail on them, wait for them to process, so. But other than that, yeah, no, I can do that later. Yeah. Just kind of trying to plan out my week here, because I go back to work tomorrow. Other than that, thank you for stopping by. The VODs will be here for a little while. I don't know if I'll even delete them from here. I probably end up will, but I will set them. I'll leave them here, let them kind of cook, and then I'll put them on the other channel. But until then, I'll see you then. I'll try and get a stream going Wednesday. I'm trying to, you know, be consistent with them. But other than that, I guess I'll see you another time. I should probably make an ending stream soon, so we're just gonna stop streaming. Peace.